One more trig video. We're going to talk about some simple trig limits. Uh, and this will eventually serve you well when you get to calculus. Basic principle, limit as x approaches c of k f of x, k is a constant, is k limit as x approaches c of f of x. Assuming this limit exists and k is some constant. In other words, you can factor the constant out of the limit. It's a very simple limit principle you'll see in calculus 1. We have two known limits we're going to assume. Limit as x goes to 0, sine x over x is 1. Limit as x goes to 0, 1 minus cosine x over x is 0. Those were from the previous assignment. I had you produce a table to identify what these limits are. They can be proven. You can prove them using something called the pinching theorem, or the squeeze theorem, or the sandwich theorem, but we're not proving it in here. You can calculus, you may see a proof. But we're going to use these limits to calculate a couple more limits. And you have some exercises in your packet you'll have to do. First of all, we have limit x goes to 0, 3 sine x over 4x. The sine x over x is a known limit, so we're going to factor 3/4 out. We get 3/4 limit x goes to 0, sine x over x. Okay, do this step in your packet, and the reason why you do this step is you're using this principle. I just don't want you to write the answer down. I want you to write the principle. You're learning the principle by factoring this out. If you just write 3/4 on the paper, I'm going to mark it wrong, simply put. Factor this out. Now this is 3/4 times 1. That limit's known to be 1, and so we get 3/4. Now here you can factor a 5 out. And then you can factor 5 out. If these two numbers, two coefficients weren't the same, we wouldn't be able to do this. If this was 5 minus 6 cosine x, this wouldn't work. You have to use some other limit technique. Now you get 5, limit x approaches 0, 1 minus cosine x over x. And then 5 times, this limit is given to be 0, and so you get 0. So there's a handful of limits you can do in your packet. They're no more difficult than this. They all work out. These can be made more complicated, and in calculus they probably will, but if you can get these simple ones down, calculus will go a lot smoother. So, okay, that concludes this video.